This is the final video for Chapter 3, Decisions. We're going to introduce one other way of making the decisions called a switch construct, and we will show how it's going to be used later in the semester to implement programs that are driven by menus. So let's introduce the switch statement. And it's really used to select statements among several alternatives. And it's an option to using the if, else if, else if, else if, else construct. Here's an example. If I want to classify a student or print out the student's classification based upon a single letter, lowercase f and S mean freshman and sophomore, underclassmen. Uppercase J and S represent seniors. So one way to implement the classification is just an if, else if. What are the choices? You have 4 choices. If the variable classification is the letter F, I know lowercase f, I know it means a freshman, and so forth. So I can do it this way. All right. Equivalently, I can write a switch that does the same thing. Now let's look at the elements of it. Notice that the key word is switch, and it really means a decision-making construct. It is followed by a left paren. Switch is not a function any more than if is a function. It's a keyword. It's a decision-making keyword. So the decision is going to be based upon, and this is important, it's going to be based upon the specific value of this variable. If the variable has a value lowercase f, I know what to do. If it's lowercase s, I know what to do. Uppercase J, uppercase S, I know what to do. Those are the 4 cases we had to handle. And if it's none of the above, I have an action that I will take, merely to say that it's invalid. All right? Is it clear that I could have 50 different things I want to do, and they are all written in a very uniform and simple way? There are a couple of elements of this construct that you need to pay attention to. One is that all of the list of choices, the list of values of interest, occur within a block. Second, each value is listed following a keyword called case. So you will say case, a value. Notice a value is listed. What kind of value is this? This is a character because it has single quotes. Let's go back. What is classification? It is a variable, a character value. So if this, whatever this variable's type is, you must list values of this type. If this was an int, you just list letters. You'd list numbers 1, 2, 3, no quotes. All right. And the last thing is that this variable must be an integer-based variable. A character is an integer-based variable. So is an int. Technically, so is a bool. So is an enumerated data type that we studied in the previous lecture. Now, here's what happens. If the value of classification is capital J, we find the J, and then this is called the case label. The colon says this is a label. This sticks on as a tag. In many ways, this is like a sign on a door. When I go past the colon, I enter the door. What do I do when I enter the door? First, I correct this error. What do I do when I enter the door? I output, the action I take is to output the word junior, followed by another statement called break. In this instance, break really means I have made my decision, I have finished everything, let me exit the construct. So when you hit break, you go to the point after the block that contains the choices. Is that pretty clear? Okay. So now let's look at the rules for a switch statement. You have the keyword switch followed by some expression that must yield an integer base type. We must have case labels for each of the values of interest. Values of interest. It is advisable that you have a default label that says what to do if the expression does not evaluate to one of these values. For each value, there is a consequence or set of actions you want to take. You terminate your set of actions by saying break. Break does what? It exits the whole construct. All right? Now, what happens if you leave off the break? If you leave this break off, then we haven't ended the execution, and we will flow directly down in the program. So we'll go down to the next thing. We'll keep going down till we hit a break or until we hit the closing brace that ends the construct. So most of the time you really want to have a break there. Now here are the rules again. The expression must be integer valued. It can be a bool, a character, an int, or an enumerated data type. The values that you list in the switch labels must be constant values. They cannot be variables. They must be constant values. You cannot have a switch label that lists the same value more than one time. Here's how it works. The expression is evaluated, and basically the value of the expression is like a sign on the door that you're looking for. So you go and find a door that has that value on it, and you use the switch label to go in through the door. That is, you go past the colon and you begin executing statements. And you execute statements till a break statement is reached or the end of the switch is reached. And if no matching value is found, the program will look for a default label and do what it says there, or it will exit the switch. All right. Now, a menu-driven program is a program that simply presents the user with some choices, and the program responds to the choices. You can implement a menu-driven program using if, else if, or you can use a switch. If you want to use an if, else if, here's an example. This program will print out some prompts. Enter a 1 to show the height, 2 to show the weight, and so forth. And once the choice is made, the program will say if choice is a 1, then display the height, and that's all. If it's 2, etc. Okay? Or we can write this as a switch. And here's the switch. I will pull up the program. This program has a few flaws in it. I have highlighted the flaws here. And we're going to see in a moment what flaw we have. So here's the program. And we're going to compile it. And we're going to run it. And here's the menu. It's asking for you to enter a choice. We're going to say 2. And 2 will show the weight. Okay? Now let's run it again and do a 1. 1 will show the height. This time let's do a 3 and see what happens. Be prepared. When I say show the age, what is going on? I say see the age and Okay, well I guess there's not a flaw. My bad. Okay. So let me take this out though, because typically we do not put blocks in here because execution begins here until it hits a break. So it is not necessary to introduce a block here. All right. With that, we're gonna end the videos on chapter 4.